So tonight is week 2. Congratulations, y'all made it to week 2. Um, Safely, hopefully. Hopefully everybody's safe. I know we've had some COVID cases at VCU, but I don't think the number is big at all. So hopefully everybody's mostly remote and staying safe. Today we are going to talk about my favorite subject, terminology. It's really not my favorite subject. This is the basic understanding of the same language, so the words and the definitions, so we can all speak the same language as class goes on. We talked last week about the difference between data and information, and I like the way the book kind of laid it out. So data is the values you store in your database. So if we look at this example record from a database table, you have a bunch of values: 12, 33, 899, 699, 23, September 1st, 2020. Can anyone tell me what those mean?
I think the only thing we know is the date. Anything else is just a number.
Yep. Anybody want to guess?
First one's a primary key.
Could be.
I mean, they're integers that probably relate to something.
Does anybody know exactly what every field in this table means?
No.
No.
That's kind of the whole point. Data on its own is pretty useless. When we make data meaningful and apply labels to it and query it and use it, then it becomes information. So if we think about that data, and maybe now I'll take it to a more denormalized form. Any more hints? Any closer guesses based on this?
Maybe devices.
Devices, okay. So what do you think the first column is? Samsung.
Brand,
Yep, brand, manufacturer. Second column
serial number,
could be a serial number, a model number. The next column. Now you can kind of guess.
Quantity, price.
Price. So yeah, okay. But that's again more. It's starting to mean something when we're not relating data to or tables to each other. But this is what it is. This is how we make that data information. So we have Samsung and a 65-inch class, whatever. This is a TV based on that model number. $899, I made that up, is the manufacturer suggested retail price. $699 is what we're actually listing it for. 23 is how many on stock, and whatever September 1st is, I don't know, I made something up. But with a user interface like the Best Buy website, it's now becoming information. We as the consumers of this website, we still don't know how the data is stored in the database, and it doesn't really matter. There's that translation point from data, raw data, to information that we can understand. So the summary of that is data is what you store, information is what you retrieve. I like looking up TVs because I want to buy a new TV. Oh, well, that showed up funny. Null. So is everyone familiar with the term null?
Yep.
Yes.
Anyone not familiar with the term null? And it's okay if you're not. All right. Well, in a database, a null value represents a missing or unknown value. A null is not a zero. A null is not an empty string. And conversely, a zero is not null. An empty string is not null. A null value means the absence of a value. It is not a value. We'll use this in our database tables to represent things that don't legitimately have a value. So the example from the book, I think, was Washington, D.C. as a city does not belong to a state, right? Every other city in the U.S. belongs to a state. Richmond is Virginia. Seattle is in Washington. Obviously, Washington, D.C. has no state. And therefore, if we had a table, excuse me, that listed cities and then the states they belonged in, the state value for Washington, D.C. would be null because it's not, there's no value to represent the state that it is in because it's not a state. So if we had a table for employees, everybody's had a job of some sort, most likely. We have two columns in this table. One is hourly wage and one is annual wage. Can someone describe like when one of those values would have a null set to it?
If somebody's not hourly,
Okay, if I was not hourly, I am not an hourly employee at Capital One, what would my data look like?
just as an annual wage for salary.
Yep, about $34,000 a year, right? And I would have a null value in my hourly rate. And conversely, or whatever, I used that word already, if I worked at a fast food restaurant as a regular line employee, I would have an hourly wage set, but I would not have an annual wage set, and that would be the null value. So this is the case where we can have one table with kind of two scenarios for a person, and depending on the legal employment status of that person, that'll help define where we would use a null value in that table.
A quick question.
Yep.
Does it depend on the data type? Like, yeah, not the data type. I'm not sure the data type or data measurement, but if it's binary or is it ordinal, does it mean that you have to put like just only two values in that column? And if you have something extra, it becomes null, right?
Yep, that's a really great question. So just to repeat, so I make sure my recording got the question, does this depend on the data type of the column in your table? For instance, if you have a Boolean or a binary value data type on a column, or if you have an integer column, or any other data type, is null always applicable? And yes, it is. The short answer is yes. Any table or any data type in a database table, in a relational database table, can have a null value, unless you, when creating that column in the database, explicitly say that that column cannot have a null value.
So when we take the data to process, like using any sort of the analytical tools, does it take into account of known values, or it just leave them out of the calculation?
Awesome question, and we cover that on the next two slides. I think you're getting ahead of me. You can't read this. Why can't you read this? There's awesome stuff in there. So null values causes issues with things like math. So I have some really cool mathematical examples in here. If you ask your database to add 3 plus 4, what do you think it tells you is the answer?
4,
3.
7.
Yeah, 7's the right answer. 3 plus 4 is 7. 3 plus null. What do you think the answer is?
Null. That's an error code.
The answer is null. I don't know if a database would actually give you an error code. I think it would just give you a null, at least in Postgres. But in the theory of databases, we're not into database implementations yet. In theory, you can't add 3 plus null because it's not a value. It is not 0. 3 plus 0 is 3, but 3 plus null is null because it's not a value. And so I had a couple other examples of math, like anywhere in an equation, if one of the values is null, the resulting number will be a null value, or an incalculatable null value.
Why
So
would 25.3 plus 4 be null?
can you read that?
On the
Oh, look, when I highlighted it's there. Weird.
On the class notes, if you download.
Oh yeah, 25 times 3 plus 4 is not null. I need to fix my copy paste there. That's an actual number. That would be 79. Thank you for calling that out. I will fix that. But the other ones will be null.
a quick question. I'm sorry, you might have already answered this, but what exactly is empty string?
So if you think, do I talk about that soon? Hold on, let me.
It was in the previous slide somewhere. So
Yeah, I referenced it. Okay, I don't explicitly talk about it. So an empty string is a string with no characters in it. So if you were writing a line of code or something, and you had, my first name, it would be, quote CHRIS quote to represent Chris. But an empty string would just be represented as quote quote, because it would be a string of length 0.
Gotcha. Thank you.
Yep. So again, that's not null. That is an actual value. It is just an empty string.
Professor, quick question here. What's stored for nulls in the database?
What's
Is it what's the binary for nulls in, say, Postgres?
I don't know if I know the answer to that. I'm sure there is some representation. If I were writing C code, it would be equivalent to the integer value 0. But I don't know what Postgres or any other database would actually store. It's got to be some pointer or reference to something that says this is null.
Okay. Thanks.
Yep. And so taking that math calculations a step further, if you look at this table below, straight out the book, you'll see product IDs, product descriptions, categories, SRPs, suggested retail price, quantity on hand, total value. What do you think would happen if you tried to get the average of all the values in the quantity on hand column? Null. Yep. And so when we start writing SQL to do calculations like this, we have to always tell the database what to do in these equations for a null value. If we wanted to calculate the average of that, we would probably set it to 0 as the default. But we can talk about that at length when we get into building our databases. So any other questions before I move on?
So does the Postgres average function really return null if there are any nulls? Because I looked it up just now and the documentation says that it ignores null. Which is what I'm used to.
Yep. So this is where the where's the book? The database design book is software independent. It is to the theory of relational databases, and so implementation on different database engines could be different. So Postgres very well may ignore them instead of treating them like a 0. More terminology. Tables. In the relational model, data is stored in relations, which are perceived by the user as tables. Tables are the structure that holds all of our records and all their attributes. And when we design our databases, tables are meant to represent one thing, one entity in the real world, one measurement, one system, one thing. So when we build our tables, all the values in that table need to be related to each other, or different instances of something, like different people or different classrooms or different car manufacturers, etc. The term tuple is the proper word for each row or record in the table. I will never say tuple unless we're talking about Python. I'll always say record or row, but that's the right term to represent each item in the database. And each item in the database has a set of attributes to it. So in the quick graphical table here, the table is defined as having 3 attributes. And in that table, we have 2 tuples, 2 records. And then each individual record has their own value for that attribute. Tables, tuples, and attributes.
And attributes and column is same thing, right?
Correct. Attributes and columns are the same thing in a relational database model. Yep.
I just find it a little bit interesting to hear the terms tuples, because I've never heard that before. Like normally people just use record or observation, or something like that.
Yeah, I don't think I've ever used the word outside of the tuple data structure in Python, and so seeing that as the like real word for a record, same thing. I was like, oh, okay, cool. That's the real word. And other than those two contexts, I don't think I've ever used that word at all. All right, now talking about each table in a database. They are that thing that holds all the data together in that domain. And every table, whether you define it or not, has a primary key. The purpose of a primary key is to identify a unique record within that table, a unique tuple in that table. You will regularly see the examples having things like client ID or patient ID, car ID, manufacturer ID, all those things. That is basically the standard way of defining a primary key for a table. When we store data in a database table, we don't know how it's stored on the disk. We're well abstracted away from that. And the interesting part of that, I think, is the logical order, meaning the way these things are stored on disk and the way these things are represented to the end user. The logical order has no importance. There's no value or no reason why records are stored in the order they're stored. And so when we have a primary key, we have a way of identifying those unique records. Yeah. So there's a good slide, and I keep getting messed up. My other monitor keeps turning off on me. There's a slide I have in a little bit that talks about the primary key value and the primary key definition and how it relates tables together and stuff. So we're going to get to that in a minute. But within a table, every record needs a unique primary key. You cannot duplicate primary keys. So if our primary key was a client ID, you could not have two clients with the same client ID. The database won't let you do that. Fields or attributes. So even the book is using multiple terms for this. We said columns, field, attribute. They're all the same. This is the way we. I have a typo. It represents the characteristic of a table because in a relational database model, the attribute is defined at the table level, which dictates what values the record must show. But I'm sorry. Let me redo this. The field is the attribute of the record. I totally said that wrong. Attributes are the record of the table. The field is where that value is stored on the record. Let me say that again. The table is defined with attributes. Client ID, first name, last name, etc. Each record in that database has values associated with those attributes. Those are the fields. So the fields are the structures that actually store data. Every field in a properly designed database contains one and only one value, and its name will identify the type of value it holds. So we're going to talk about database normalization at some point. And one of the normalization steps is to make sure every record has one value in each attribute. Did my clarification, restatement of all that still make
So the
sense?
field it's basically the container, right?
Yes. So
Okay.
this is the field. So if you can't see what I'm highlighting the actual description for row 7001 in product ID, or in the product table. So these are the fields because they have the actual values in them. The top row represents those attributes or the definition of the table.
So which one is a record then?
Each of these rows is a record. There.
So, good question. Does it like how is it associated with metadata, the field and metadata? Are they the same thing? Because
Yeah, so I'm trying to think of the right answer. The term metadata is a specific thing in data management. It's data about data. So when we're talking about databases, there's no metadata. There's the table and the table structure, which is the attributes define the table structure. What columns will be in the table?
so to simply, it's just kind of like in database management, we don't have in that word we don't have the definition of metadata.
Correct.
Metadata data management.
Yep.
All right, get it. Thank you.
How is database schema? Is database schema the same thing as database structure?
It is. So the database schema is your definition of tables, attributes, and keys, indexes, those kind of things. That's the schema of your database. It has nothing to do with the actual data that's in the database. So if you think about 2 steps of creating a database, the first step is you define the structure of your tables. That's your schema. The second step is you put data into your database. All the data you put into your database has to match your schema. Like in this example of products, I couldn't decide to put another column or another field in for one of these records if it's not defined in the table schema. Did that make sense?
Yes, fine.
All right. So types of fields, and these are defined when you're defining your attributes. So each field has to follow the definition of the attribute, right, or the property, the attribute, the column. You can have a field that has multiple values or multiple distinct items in it. We don't do that, but you can. So as an example, you could define a column that was how would you even do that? I don't even know how you would do that. If you were building a spreadsheet in Excel or Google Sheets or whatever, and you made a column that had if you had a sheet representing people, employees, students, whatever. If one of those columns you typed in their user or their first name, last name, and their address, you're storing 2 distinct things about that user, the name and the address. And even more granular, the first name, the last name, the street address, the city, state, zip. That would be the distinct items. So when we normalize our database, we don't put all those things into one column. We will design our table so each of those attributes or each of those distinct items, to use the term here, is its own column. Now what you can do, a multi-valued field, you could have multiple instances of the same data type. So you could have an array of strings. You could have multiple integers. If you were, what would be a good example? I can't come up with a good example. but there are possibilities of having multiple values in a single attribute or in a single field. The second one here is less bad than the first when it comes to database design. A multi-part field is never a good practice in a relational database. A multi-valued field is better, but still it's not a practice we typically follow. In both of these cases, in the first one you would define multiple attributes, and in the second one you would define a one-to-many relationship, a one-to-many table structure. Now a calculated field, you will see this regularly. Primarily you'll see this in database views, which we're going to talk about in a second. But in this, the example in the book was a full name column, which is calculated as a string concatenation of the first name and the last name columns or attributes of that table. So when you are a application or a data analyst entering data into that table, you wouldn't ever put a value into that calculated field. You would update the source fields, the first and the last name, and the calculated field of full name would be calculated. I'm trying to remember if I didn't put a example in here, but that one was in the book.
Quick question.
Yep.
Is it okay?
Absolutely, always. You guys are paying lots of money to be here, and so I am here to teach you.
Thank you. For the multi-part compass field, does it mean like, let's say if one person living at one location, so we have the street number, we have county, and we have state, so we can put everything in one field, and then when it comes to multi-valued field, we have multiple people living in the same county, right? One way to put it?
That would be, yeah, but again, those would be the bad ways of designing your table. Right? If you had a table representing counties and you had a attribute that was a list of people, that's not the right way to design it.
Because I'm trying to distinguish between multi-part and multi-value field.
Yeah, and I think I like my example of the person's name and the person's address. They're two very different things. And the only way I can actually think of doing that in a structured format would be in a spreadsheet. I don't know how to accomplish that in a database because it's so wrong. But can you visualize it in a database or in a spreadsheet? Like somebody just types a whole bunch of information in one of the cells?
Mm-hmm. Okay. Thank you.
Yep. Records, we have beat this one up. A record is a row, is a tuple. This is the unique instance. Geez, my typing last night was awful. I'll fix all this. Each record is a unique instance of the subject of the table. I like the term subject. I was saying entities or something like that earlier. But subject is a really good abstract term. So the example in the book, each client in the client table will represent a client in real life. Each record in the table has a unique primary key client ID. So this one was going to be hard for me to figure out how to make those tables in Markdown, and so I just took a picture of the book. A view you can think of as a virtual table composed of fields from one or more tables in a database. So if we look at I don't even think I have the whole picture here. Dang it. The relational model refers to a view being virtual because it draws data from a base table rather than storing its own data. So a table is eventually a physical structure on your disk that stores data. When I have a record in my table for student Zachary Ehrlich, those values are written on a disk somewhere that my database has access to. When I'm creating a view, I'm essentially making a to the user, it looks like a table, but behind the scenes, the data is stored in those source tables. So now I got to get the book to find what the bottom view is labeled. So if you have your book, actually, I think I can do this too. All right, can you all see this? There we go. So here we have 3 source tables: students, student instruments, and instruments. Students is the definition of all the students in the class or school. Instruments is that kind of master list of available instruments that the school owns. The student instruments table here is a link between the students table and the instruments table, and the added value here is the checkout date. So this is very similar to like modeling a library, right? You have students and books, and you would check out books. But here, when I go to band class, I say, well, I'm going to play the Stratocaster guitar, and I check that out on February 6, 2012. Because my name is Joe Rosales. So you can see we've got these 3 tables with important information for someone who is looking at who has what instrument checked out. And so we can create a view that pulls data from those 3 tables and presents it in a different way. So the view, we can have the student first name and last name, and we know those come from the student table. The instrument description comes from the instruments table, and the checkout date comes from the student instruments table. Everybody follow me along so far?
Yes.
Okay.
There's a quick question.
Yep.
So student instrument, is it an associate table that was created to, because it has like many-to-many relationships?
That's exactly right.
Gotcha.
So that is a sneak peek. This is how you structure a many-to-many relationship in a database. We'll talk about that at length in the future. The business domain here probably doesn't allow more than one student to check out the same instrument. Maybe it does, who knows. But yes, this linking table or this association table, student instruments, is how we model many-to-many. So today I might have this one instrument checked out. Tomorrow Joe Rosales might. The day after Susan Black might. But that's that many-to-many relationship. But for when it comes to the database views, the top 3 real source tables, that data is persisted on disk somewhere. The data in the virtual table or the view is not persisted on its own. It is just pulling or viewing the data from other tables. The way you build this is you write a SQL query to present the data how you want, and then you can define that as a view in the database. And the database then does things to optimize it and all that kind of stuff. But now you can query instrument assignments as if it were a table, even though it's not a table. If that's too abstract, we will cover it in detail when we start writing code.
Where exactly is it defined? Is it still defined in the schema?
It is. Yep, it is still defined in that schema phase. So we'll start using the terms DDL, data definition language. That's creating tables, creating attributes, all that, creating keys. You still define a view in your DDL, in your schema definition.
Okay.
So if there was no data in those tables, those source tables, the view would have no data virtually. There would be no virtual data. But that is, if you want to get more detail from the book, that is around page 54. This picture's on page 55. Oh, crap. Keys. So a primary key is that field or group of fields that uniquely identify each record within a table. This can be more than one. This can be more than one column, more than one attribute can be combined to make a primary key. That is completely acceptable. That is not a bad practice. It just depends on your data model. Primary key values, oh, this is the slide I like. The values in the primary key identify the specific record in the whole table. They say database here. In my mind, it's table, but 601. So the agent ID, each primary key value represents that record in the table. The primary key field, so the actual agent ID attribute that's defined as part of the table, identifies that table in the entire database. So you'll see when we start making references to the primary key fields, there's only one primary key for each table. So it helps uniquely identify the table in the database. The value represents the record, the field represents the table. And this helps table level integrity and helps establish relationships with other tables. The table level integrity is the enforcement that each record must have a unique primary key. So if we were defining, let's make up an example, we're defining a student's table. Each of you has a student ID with VCU. Your student ID is very well likely the primary key in one or more database, represented as one or more values for a primary key in the table in the databases at VCU. Your student ID uniquely identifies you. Another way of building a table like that, with shortcomings, we could use first name, last name, and birth date as an example as the primary key in our database. There are shortcomings. If you have a twin with the same name as you, which would be weird, that would break that data model. But you could do that. And there are use cases in designing databases where a multi-field or a multi-attribute primary key is completely acceptable. And that's the kind of rule that enforces some integrity. Having a unique ID, like an agent ID, that's kind of standard practice, and it will help you maintain one record for a person. But I think that's not what they're going for that table level integrity. Maybe it is. And then the relationships with other tables in the database, that's what when we start talking about those one-to-many, many-to-many relationships, it's always keyed or based on primary keys. So index is a structure that an RDBMS provides to improve data processing speeds. So I thought it was funny in the book. They said this has nothing to do with the logical database structure, which is very true. It's not the same thing as a key. So the key is that primary identifier. That's our primary key is the unique identifier in a table. A foreign key, which we didn't get, I didn't have in here because that's in the next section where we talk about relationships at length. The foreign key is a table's reference to another table's primary key. So our users table, or going back to these examples, our student ID is the primary key in that student's table. the student ID in the student instruments table is a foreign key that references the primary key of the students table. Just like instrument ID in the student instruments table is a foreign key representing the instrument ID, which is the primary key in the instruments table. And going back to those multi-attribute primary keys, your primary key in this database table would probably be student ID and instrument ID to uniquely represent each record in the table. So when we're talking a table like students, internally we're only talking about students. Student ID is the primary key. When we're in another table referencing the students table, then the student ID is the foreign key. Sorry, I was cutting somebody off.
No, you didn't. I just have a quick question about view. Are we able to say view, or we just, is it temporary and it'll be gone after we done?
Sorry, what about you're asking about the view?
Yeah, are we able to say view?
Oh yeah. Views are defined as a structure in the database. It's defined as a structure in the database. So it doesn't go away unless you delete it.
Yes. Okay.
Now, if anybody has database experience and you're thinking about materialized views, we're not there yet. If you don't know what I'm talking, about, ignore it. There's a question.
Yeah, so what's the difference between student instruments table and the view?
So students exists independent of anything else. It is an actual physical table that you insert data into. With me?
I mean the student instruments, the one that combines the students and the instruments. How this table is different than the view at the below that
Okay.
we created. Yeah, this one.
Yep. So ignore the view for now. Okay. I'm putting my hand over it as if you can see that. Ignore the view. So like this picture, ignore the view. Students is your student information. Instruments, as an example, is all the instruments this school owns, right?
Right.
Student instruments here links those two together to enable a student, or to enable us to track a student who checks out an instrument.
Okay.
Okay?
I got it.
So
Yeah.
let me tell you why we do a view. So if we were querying this and we were writing a query, our SQL would be kind of complex. We would be selecting from the students table, outer joining to the student instrument table, outer joining to the instruments table. It's not overly complex SQL. You guys will master that in a couple of weeks. But it's going to end up being 12 lines of SQL code. And so if you were going to use that in an application, the code to run that query could get complicated. And if you change the underlying structure, you have to change your queries. When you build a view, the database hides all of the complexity of the joins. And it presents you with the data you need. The first name, last name, instrument description, and checkout date. It doesn't ignore the things like the student IDs. It just doesn't show them to you when you're looking at that view as a table. Now, I thought I wrote it somewhere. One big advantage for a view is, imagine I was a database administrator and I had to manage this stuff. And we have some developers who are going to write data to put them into these tables. But you are the teacher in the band classroom. And we gave you access to the database so you can see what student has what instrument. Asking a band director to write a 12-line SQL statement is kind of, that's mean. Your band director is probably not going to be able to write a 12-line SQL statement. So what you would do, you would only give that user permissions to see the view. I was going to say to view the view. That user would only have permissions to get access to the view itself, because then you can abstract the underlying data structures from them. So if it was something like Microsoft Access or SQL Server, you could build a simple interface for them to just see the data in the view without having them to know what the underlying database structures. I thought I covered that.
Thank you.
Oh, yeah, here we go. Can be used to prevent certain users. Oh, yeah, I got befuddled because I had half the picture there. So it simplifies working with the data across the multiple tables, right? You don't have to write the 12 lines of SQL. It can be used to prevent certain users access to the core tables, the student instruments, and instruments table in this example, and can be used to implement data integrity, known as a validation view. Good questions, though. I like them. Looking at our time, we've got about 9 minutes left. That was the material I have for tonight. And then I think so any questions about that before we move on to my Docker question?
I just have a very quick question. Are both textbooks required for the class?
Absolutely, yep.
Cool. Thank you.
You're welcome. I had 3, but I dropped 1, so you only have to get 2.
No.
So are we still in chapter 1 or chapter 2?
This is chapter 3.
Oh, I'm sorry.
No, it's okay. And I think we went up to page. Up to page 58, 59. So page 59 starts talking about relationship terms, which we'll cover next week. Or Thursday. Sorry, we'll cover Thursday. All right, let me stop my recording.